Alrighty guys, sorry for kind of this weird setup. Hopefully you can see what I'm doing okay. So here's our notes that we're gonna fill out together today. We're gonna do like a trifold, kind of like a brochure. So fold that in, fold that in. And we're probably not gonna do all these examples today. I just don't want it to be a super long video, but we definitely wanna go over the steps to how you graph these and then try a couple, and then I'll probably post a second video for more examples. Okay, so the first thing always is we want to factor. So if we have something that is not in factored form, we want to make sure that we get it in factored form. The first thing I think about after that are finding any holes. So we find holes from canceled factors. So like factors that divided out, we set equal to 0 for the x value and then plug in to find y. Now your hole is kind of like a guide point that you can use to help you graph better, but I generally don't start off by plotting it right away. I kind of find some other things first, usually my asymptotes, because my asymptotes are the best way to know where my graph's going to show up. So that leads us to the second thing we want to think about finding, which are our vertical asymptotes. So our vertical asymptotes come from factors in the denominator still. So whatever is in your denominator, like if you have x minus d, then your vertical asymptote is going to be at x equals positive d. So always opposite. Sorry if this is kind of hard to see. Next thing we want to think about are any horizontal or oblique or slant asymptotes. So to figure out if you have horizontal or slanted asymptotes, you need to check the degree. So check degree, which is our largest exponent. And so if the degree of the numerator equals the degree of the denominator, so if they're equal to each other, then my horizontal asymptote, we just want to divide out leading coefficients. So that's one option. Or maybe the numerator is smaller than the denominator, and that's the case that I can't really divide. And so my horizontal asymptote is just y equals 0. Or the only other thing that can happen is that your numerator is larger than your denominator. And if that's the case, you can divide, and so we will divide. And so this is where you get a horizontal or a slanted asymptote rather. So like a y equals mx plus b situation by synthetically dividing to get that. And like once I kind of have my vertical asymptote, my horizontal asymptotes, I'm going to graph those because that's going to split your quadrants up for you so that you can kind of figure out where your hyperbola branches are going to go. You could plot your hole at that point to sort of tell you, okay, I'm going to have a hyperbola branch in this quadrant, which can then help you to figure out where your other branches will go. But some other things that can be useful, like some more easy points to find, are X-Intercepts. So we can find our X-Intercepts by the factors in the numerator. So like if I have in the numerator x minus n, then I have an X-Intercept at positive n. And I could go plot that point. There could be more than one, and that would be really nice if there was, because it tells you even more information. We can also pretty easily find our Y-intercept. So ignore x's, or like plug in 0 for x, and solve. That should be a pretty easy thing to do because it's usually just going to be a number divided by a number. So, and then afterwards, this is just like kind of, if you need to, we can find additional points. So if needed, plug in X values near the vertical asymptote. That'll kind of be your best bet to finding good points that will help you graph a really nice looking graph. Then finally, domain. This is going to be what X cannot be, and these are usually your holes and vertical asymptotes, because we talked about how it's all except for a few. And then range, same idea. Your range will be anything except for holes and horizontal asymptotes. If you have a slant one, then I would not really worry about that. It's probably going to be all if you have slant and no hole. So just keep that in mind. But let's try to graph a couple. Okay, so looking at this first one here, and I'm going to try my best so you can see. We want to factor because we are not in factored form. The numerator is, but the denominator is not. We can do x minus 2, x plus 2. And then nothing cancels, so there's no hole. Because holes come from canceled factors. So no holes. We have horizontal asymptotes. I'm going to actually think about these in the opposite order. That's super annoying that I put these in the wrong order like that. So thinking about vertical asymptotes, I'm going to look at my denominator, and we actually have two. One at 2 and one at negative 2. And then I'm going to think about my horizontal asymptote, and my horizontal asymptote, so the numerator's degree or exponent is 1. The denominator is 2. So since this is larger or smaller rather, we are going to have a horizontal asymptote of 0, right? So because numerator is less, it's going to be 0. And so now that I have my asymptotes, I'm going to start drawing my graph a little bit. So I'm going to put my horizontal asymptote here, my vertical at negative 2, also positive 2, which kind of splits my graph up into 6 quadrants. So I'm probably going to have more than just 2 hyperbola branches here. And I don't have a hole to really guide where anything is happening. So that's definitely why we got to go find some new points. So first of all, let's think about our X-intercepts. That comes from my numerator. And so I have an X-intercept at 1 right here. I can also think about my Y-intercept, and actually finding the Y-intercept is easier when you're in standard form like this. So if I ignore those X's, my Y-intercept is at 1/4. So like right here, which like isn't helping me a ton. It's kind of annoying. I can see that this is gonna go up, and so eventually it's gonna like hug this asymptote over here. But like, what the heck is it doing on the other side? And so here's where we might want to plug some points in. Like maybe I want to plug in 1.5. But for right now, let's see what's happening at 3. So if I pick x equals 3 to plug in, we're going to have 3 minus 1 over 9 minus 4, because we square it. So 2 over 5. So at x equals 3, we're at 2/5. That's like here-ish. And then I don't know, let's see what happens at 6 as well, just to see. I mean, like it is looking like it's going to follow this asymptote right here and kind of do this, but let's just double check. So 6 minus 1 will be 5, and then 36 minus 4 is 32. Yeah, that's going to be real teeny tiny, so it's totally getting close to this asymptote, and then it's going to go up here. Now the thing is, and you're going to notice this the more you graph these, if you have an asymptote up here, then this middle portion can also be up here. So this is going to come down and follow this asymptote down. And traditionally what happens here, if you have a cubic in the middle, then this asymptote, or this quadrant with a hyperbola branch, is kind of filling in where you don't have graph. And then the other one is going to be in the opposite side. So it's just going to be down here. Like we can plug in -5 to see that, but it'll totally do that. Because you kind of always have this pattern where it like fills in where the graph is not. Like I don't have a line here, so that's why my branch is down here. And then when we talk about domain and range, so domain X cannot be 2 or -2 because those are my asymptotes. And range, now normally I would say that Y cannot be 0, but at this spot it is. So it kind of got filled in. So that's all. Okay, let's try another. So looking at this next one here, we want to factor that, and we're going to have x minus 4, x plus 1 over x. And again, nothing cancels, so no holes. I'm going to think about vertical asymptotes next, so that is what makes my denominator 0. I'm going to think about horizontal asymptotes, and this time the numerator is larger, so we're going to actually have a slanted one by dividing. So we're going to do 0. And whenever we synthetically divide, we divide in standard form. So 1, -3, -4, and we want to drop it down, multiply, then add. Remainder doesn't matter, and so my slant is at y equals x minus 3 because we're always 1 degree less. And so now we can go graph our asymptote. So we have one at x equals 0. And then we're going to have this slanty one at y equals x minus 3. So starting here at -3. And then we're going to have a slope of 1. So it's kind of making this x. But we still have like 4 quadrants. So 1, 2, 3, 4. We just have like an x quadrant instead, which is kind of funky. But let's go get some points to help us figure out where the heck our graph is. So if we think about x-intercepts next, we look at our numerator for those. We actually have 2, one at 4, and also -1. And this is super helpful because the -1 is like in this quadrant, and then the 4 is in a completely different quadrant. That's super helpful because that totally shows where our branches have to be. Also, if we think about a y-intercept, I'm actually going to be dividing by 0, so there is none. So yeah, I mean, I could plug in 1 just to double check here. And actually plugging in 1 is not so bad. So let's do that real quick. If I plug in 1, we'll have 1 minus 3 minus 4 over 1. So like -6. So yeah, I can totally see that my graph is like doing this thing here. Like it's going to follow this asymptote and then it's going to follow that asymptote up, which means that over here, this point will do the same thing. Now you could plug in something like -4, but like it's just going to follow this asymptote up and then it's going to get close to this asymptote over here. Your asymptotes always pull your graph closer towards them. So the asymptotes are super helpful. Okay, last one I'm going to try in this video again because I don't want it to be like totally epic. I feel like it's already epically long. I'm so sorry. First things first, we want to factor. So I actually can factor my numerator, although it's not super helpful because I still have no hole. So no holes, nothing canceled. Next, I want to think about my vertical asymptote, which happens where the denominator is 0. So that's actually half because we want to like bottoms down. So that's kind of a weird asymptote. It's fine though, just plot half. Horizontal asymptote. This time, the numerator and denominator are equal, and so we just divide, and 4 divided by 2 is 2. So we have our horizontal asymptote at 2. So again, I have 4 quadrants here, which probably means I'm going to have opposite branches, like we typically do. So let's try to get some points to help us find those. So first of all, x-intercept happens where the numerator is 0, so at -1/2. So like right here. And that's already kind of telling me, okay, like I'm going to have a branch here. I'm probably going to have a branch here as well. They're usually always opposites of each other. But let's just see. We got y-intercept at -2, so that also makes sense. We kind of have a hyperbola branch over here. And then just to double check, like maybe I'll plug in 2 because that'll show me if my graph is up here or not. So let's say x is 2. And so we'll have 4 times 2, which is 8 plus 2, over 2 times 2, which is 4 minus 1. So 10 over 3, which is like 3-ish. So yeah, 2 comma 3-ish. Heck yeah. A little more than 3. So we're just going to throw that branch up in there. Okay, so I'm going to leave that here. Hopefully that helps a little bit. We do have 3 more, but I'm going to save those for a different video. Again, just not make this one epically long. So hopefully that helps, guys. Just keep those steps in mind. These steps here are good. Also, the notes that we took last Friday can be super helpful. So good luck.